All right, college algebra, we're looking at exponential functions today, section 4.2. Okay, in this first problem here, we're looking at the graph of this function right here. We got 13 to the k power. Okay, it passes through these 3 points. If I put -1 in for k, that's 13 to the -1 power, which is 1 over 13 to the +1 power. So when I put -1 in, that's 1/13. Now here's the 2 points we're mainly concerned about. If I put 0 in, 13 to the 0 power is 1. Anything to the 0 power is 1. And then 1 power. If I put 1 in, 13 to the 1 power would be 13. And these are the 2 points we're mostly concerned about. Look here. Suppose I have this function and it's 3 to the x power. Okay? We're looking at these 2 points as our main 2 points right here. When x is 0, when x is 1. 3 to the 0 power would be 1. 3 to the 1 power would be 3. Okay? Look at another one. Suppose this is 5 to the x. Guess what my 2 point values would be for x and f of x? Well, this is going to be 0 and 1. 5 to the 0 power is 1. 5 to the 1 power is 5. So you can see how this sets up here. I'm always going to have 0, 1 as one of my points for this exponential equation every time. 0, 1 will always be a point. And then the other point that we're mainly concerned about would be 1, 3, or 1, 5, whatever this base number is. 1, 3, 1, 5, or suppose I have another one. Maybe it's 8 to the x power. Well, then guess what my points are? 0, 1, 1, 8. Okay? Here, look at another one. Suppose I have this. 2 to the x power. 0, 1, 1, 2. Those would be my points I look for. And these 2 points help us graph the graph every time. Okay? What we have is this. Look at this first problem here. It says to graph this one 10 to the x power. Well, guess what my 2 points are? 0, 1, 1, 10. That'd be my 2 points that help me graph this. Now, when you graph this, you have to remember when you graph an exponential function, there's an asymptote on the axis here. There's no way for an exponential to be negative, so there's no way for it to be down here. So what happens is it's got this tail that comes like this, and then it starts growing, and it hits 0, 1 right there. And then it hits 1, 10, or whatever that second point is, it hits it right there. So these 2 main points are all we're concerned about. We got this tail, and it comes and hits that point and then curves to that point right there. And that's what an exponential function looks like. You actually see this graph right here, this exponential. You see this on the COVID crisis that we're having. This is how it first started out in March of 2020. It was down here like this because we didn't have anybody that had COVID back in February. Then in March, all of a sudden it started doing this and it just took off like that, exponentially. You might hear this word mentioned sometimes when they're talking about COVID and the exponential aspect of it. But that's what we're looking at in this lesson is the exponential equation. So on this one here, graph this one, y equals 10 to the x power. Okay, well, there's only one graph of these 4 graphs that even looks right, is this one right here. So it's got this tail, and it curves and does this. But see, it goes through 0, 1 right here, and it goes through 1, 10, which is way up here. So that's the graph right there. Okay, number 3 here says graph this one. Now this is 1/5. Now here's a funny thing. If this number here is less than 1, it's going to invert this thing, so it's going to make it do something like this. Where 0, 1 is still a point, but it's inverted, and it has the tail to the right instead of the tail being normally to the left. So looking at this one here, I think we're looking at this one, D. Okay. Well, all right. Number 4. So here's another one here. 2. Now, right here, when we have this negative right here, this negative in the exponent is going to reflect it kind of like the fraction did. It's going to make the tail come over here to the right again. So it looks like this one here. Okay. So when you have, let's do this right here. Y equals 2 to the negative x versus y equals 1/2 to the positive x. These two right here are the exact same thing. Now what you can do, since this is negative exponent, you can flip this 2 over 1 to a 1 over 2, and that would get rid of the exponent, get rid of the negative in the exponent, which is what we have here. So if you have a negative in front of your exponent or you have a fraction base, these two are the exact same thing. All right, so here we go. We're going to graph one of these. All right, 6 to the x power, but then we got this plus 4. All right, this plus 4 is going to shift my whole asymptote. So like here, 1, 2, 3, 4, my asymptote's going to move up to here now. Okay, because of this plus 4. It's just the transformations like we talked about before. 6 to the x, well, what I'm looking at here, 6 to the 0 power would be 1, plus 4 would be 5. And then 6 to the 1 power would be 6, plus 4 would be 10. Oh, this is supposed to be a 0. So these are my 2 points. So 0, 5 is right there, and then 1, 10 is right there. And you can see the tail's on this side, and it curves up to these 2 points right there. And that's how you graph it. Okay. Now, there's graphing techniques that they use on the program. I think you'll be able to figure those out. The domain here, now every time my domain would be negative infinity to positive infinity. Every time my domain is that. Now my range can't be, because see, there's this asymptote and it can't go below that. So my range on this one is 4 to infinity. Because see, 4 is the lowest it goes with the asymptote here, 4 to infinity. Okay. Number 6. All right, let's graph this one. Now notice we've got a negative in front of the 3. It's not in front of the x. So what this is going to do is, normally my graph goes like this, but with this negative being out front, it's going to flip it and make it go down like this. Okay. All right, so basically what we can do is, this point right here, 0, 1 is the point we normally have. Okay, see this plus 2 here? This plus 2 is going to be moving it to the left 2. So it's going to move it 1, 2 to the left here. My asymptote is not moving any because it don't have any plus or minus number out here. So my asymptote's going to stay there. But this point moves to here. And then the point that's usually at 1, 3 for this, since it's the base 3, it's going to move that way too. So my tail will be here, and then it goes up like this. Okay. Now what's the domain and range? Well, domain every time, man. Negative infinity to positive infinity. The range, it goes from 0 to infinity. And there never is a bracket on this, never. Because it never will equal 0. So it's always parentheses every time. Okay. Using the graphing tool, I probably should do one of these on the computer actually, so you can see the graphing tool worked out. But see, my negative is in front of the x, so what that means now on this one, my tail is going to move to the right side, so it's going to be looking like that. Okay, so basically 3 to the negative 0 power would be 3 to the 0 power, which is 1. And then 3 to the negative, if I put negative 1 in there, let's make that 3 to the 1 power, which is 3. So negative 1 would be 3. And my tail would be going this way. So that's how it would look. My domain, though, negative infinity to positive infinity. My range, the lowest it goes is 0, the highest it goes is infinity, so it'll be 0 to infinity. Okay. Number 8. All right, graph this one. All right, so now here we got this minus 2 is making it go this way 2 to the right, and this plus 1 is going to make it go up 1. So normally my 2 points for this It'd be here and here. Because, again, 0, 1, 1, 3. 3 to the 0 power is 1, 3 to the 1 power would be 3. So there's where these points normally would be. So basically, they're both going to move that way too. So this will move this way too and up 1. That one will move to there. This will go this way too and up 1. That'll go to there. And my asymptote now goes up 1. So my asymptote's going to be here now, up 1. So basically my tail is here, and you can see it goes through these 2 points there. And that's how the graph will look. Okay, the domain, negative infinity to positive infinity. The range, well, the lowest it goes this time is 1, and it goes up to infinity. Okay, let's go to here. Same deal, this base is 2, so if I have 2 to the x, that's going to give me 0, 1, and 1, 2. There's my 2 points. Well, I've got this shift on it, so 0, 1 normally is here. Okay, it's going to go 2 to the left and down 4. So 2 to the left and 1, 2, 3, 4. It's going to go to there. And then this point here, 1, 2, is normally here. It's going to move it 2 to the left. See, this plus 2 is going to move it that way too, and the 4 is going to move it down 4. So over 2, 1, 2, 3, moves to there. And then my asymptote normally is here, but since I've got this negative 4, which is going to shift it down, it's going to go down 1, 2, 3, 4. So the asymptote's going to go down to here. And you can see my 2 points. So you got to have these 2 points in the asymptote, and that pretty much tells you how it's going to go. And of course my domain, we knew this answer before we even done it. Now my range, the lowest it goes is negative 4, and it goes to infinity. Okay. Now we have some, we're going to solve. 16 to the x power is 4. 16 to what power is 4? I think it's a 1/2. 16 to the 1/2 power is 4, because 4 is the square root of 16. Now what you can do on this, 16 to the x power equals 4 is the square root of 16. So we could just rewrite that as the square root of 16. So that means 16 to the x power equals 16 to the 1/2 power. And since the bases are the same, the exponents have to be the same. That's what we'll do down here on this one. 3 to the 2x minus 3 power equals 9. Well, 9 is 3 squared. All right, so that means this will equal that. So 2x minus 3 equals 2. So I add 3 to both sides. 2x equals 5, and then divide by 2, x equals 5/2. Okay. Just a few more problems. Here's one here. Okay, I've got e to this power equals e to that. All right, so that means e to the 11x minus 1 equals e to the 9x. I'm just doing a power of a power there, so that means 9 times x. Now, since these bases are the same, these exponents have to be the same. So 11x minus 1 equals 9x. And I just saw that. I'm going to minus 11x this time. Negative 1 equals negative 2x, and then divide by negative 2. And that means x equals, that's just a 1/2. Okay. This one here, what we got to do is get our bases the same. And I think what I got here, 81 is 3 to the 4th power, 27 is 3 to the 3rd power. So what I have here then is I've got 3 to the 4th power to the 3x power equals 3 to the 3rd power to the x plus 2 power. Okay? And now 4 times 3x will be 12x. And then 3 times this will be 3x plus 6. And then I'm just going to solve this equation right here. If I minus 3x, I get 9x equals 6, and then divide by 9. That's 2/3. Okay. Here we have x to the 5/3 equals 32. Now when you have a power like this, you can do a power of a power, which would be a 3/5 power on both sides. Here, let me write this out better. Okay, so I've got x to the 5/3 power equals 32. Okay, so basically what I'm doing here is I'm raising this to the 3/5 power on both sides. And when I do that, the 3's cancel, the 5's cancel, so x equals, and I do 32 to the 3/5 power, which I think comes out to be 8. The 5th root of 32 would be 2 to the 3rd power is 8. Yeah, that's the answer. Okay, you just use your calculator for that, though. Right here, 1/64 equals b to the -3. So what I'm going to do here is I'm going to do -1/3 on both sides. Okay, let me write this one over. All right, so I got 1/64 equals b to the -3. Now what you got to do is, this is 1/3. So these will cancel out. These will cancel out, so I just have b. Because it's a power of a power, you just multiply those. And then the -1/3. All right, since this is negative, it's going to, now you can just punch this in your calculator, but since this is a negative power, that's the same thing as 64/1 to the +1/3 power, which comes out to be 4. The answer should be 4. Okay, I got the answers right here. That was 15. Right here you can see the answer. 15's 4. Okay. Same thing on 16 here. All right, so on 16, we got x to the 5/7 equals -32. All right, so I'm going to do 7/5, which is the reciprocal. The 7's cancel, the 5's cancel, x equals, and I do -32 to the 7/5. Let's see here, -128. I did it in my head there. I think that's right. Yeah, you see there, 16, -128. Okay, then we've got some interest problems. Okay. Number 17 says, find the present value that will grow to $26,000 if interest is 6% compounded quarterly for 11 quarters. Okay. All right. So we have this equation. Your accumulated value equals your present value, or your principal, times 1 plus r, your interest rate, divided by n, to the nt power. Okay, this is the equation we use for this. Okay. A is the accumulated value. You might write these down, okay? P, this is the present value, or principal. Okay. All right. Then we have R. That's your interest rate. We got to change it to a decimal though. And then we have N. This is a number of compoundings per year. And then T is time in years. Okay, so you might write these down, this equation here, or just take a picture of it with your phone if you want to, because we'll be using these a little bit in this chapter, namely on this problem here too. So on 17, it says find the present value that will grow to 26,000. So 26,000, that's your accumulated value. That goes right here. The present value we don't know. Okay, but it's going to be 1 plus the rate, which which it says the rate is 6%, so that's 0.06. Okay, it's compounded quarterly, which means 4 times in a year. So that means n is 4. And it says here there's 11 quarters, which means it's almost 3 years, but I'm just going to put 11 right there. See, this is n times t, which n is how many times it's compounded per year, which is 4 times your time, which in this case I believe is 2.75 years. And if I multiply those, I get 11. But I just put 11. And so I'm going to solve this equation here. All right, so right here, all this right here, I can type that in the calculator. So I have 26,000 equals P times whatever that comes out to. All right, so I'm punching in here. I've got parentheses 1 plus 0.06 divided by 4 to the 11 power. And that's this number right here. Okay? And so to solve for P, I just divide both sides by that. And that'll cancel off, and P equals this. All right, now what you can do, since I've got that on the calculator already, I'm just going to do this, let's see here, I think it's, right here, yeah, x to the negative 1 right here. I'm looking for this button right here. I'm going to hit that, which flips this thing and divides. I'm going to times it by 26,000. And there you go, 22,072. 22,072.26. And that's what the present value was. This 22,000 grew to 26,000 in just a little over 2.5 years. And let's see here. I got the answer right. There it is. Okay. Now what I did there with that button here, you just divide both sides by this thing right here. Don't worry about the button thing I did. I just did that as a little shortcut. Okay, moving on to 18. Find the present value that will grow to $2,000 if the annual interest rate is 8.5 compounded quarterly for 8 years. All right, so let me write my equation up here again. A equals P 1 plus R over N to the NT power. Okay, so the present value I don't know again. It's going to grow to 2,000. That's going to be my accumulated value. I've got 1 plus, where's my rate, which is 0.085. Compounded quarterly again, which is 4. And I'm going to put 4 here for N, and then it's 8 years, which would be an 8 there. Okay, so again, all this, I can type that all in the calculator again. So basically, now what I'm going to do here is going to be 2,000 divided by that. So this time what I'm going to do is I'm just going to do 2,000 divided by, and then I'm going to put all that in parentheses. So I've got the parentheses that's here. I'm going to have parentheses around this whole thing, so I've got to have these red parentheses and those black ones. So like right here, as I'm typing this in, I got this parenthesis, which is the red one, and I got to have that parenthesis there, and I'm going to have 1 plus, plus 0.085 divided by 4, okay, parenthesis, and then to the power of, I'm going to go ahead and do 4 times 8, which is 32, and then I'm going to put that parenthesis. And there you go, 1,020, 48. This 8 makes a 7 go up to 8. So 1,020, 48. There's my answer. And look at there, baby, we got it. We got it, man, we got it. All right, one more problem, number 19. Find the required annual interest rate to the nearest tenth of a percent for 1,300 to grow to 1,700 if the interest is compounded quarterly for 5 years. Okay, what was all that? Well, here's my equation. It's an R right there. Okay, there's my equation. Let me scoop this up a little bit. It tells us the present value and the future value. So the present value is 1,300. It's going to grow to 1,700. This is my accumulated value. The rate here, okay, that's what we want to find. We don't know the rate. But it's compounded quarterly, which means n is 4. And this is in there 5 years, so this is 5. Okay. Now in this one, since r is inside here, and we don't know that, I'm going to have to divide both sides by 1,300 first to make this cancel off. Okay. Now this right here probably not going to divide good. I'm just going to leave it as a fraction because I can just type in 17 over 13 easier than I can a bunch of numbers. And that way I'm not rounding it none. Okay, but the zeros will cancel off. That's just 17 over 13. Now right here, I've got 1 plus r over 4 to the 20 power. 4 times 5 is 20. Okay, now what I'm going to do here is, since that's the 20th power, I'm going to do it to the 1 over 20 power, which is what we just did a while ago. So 20 to the 1 over 20 will cancel. So what I have here now, I've got 17 over 13 to the 1 over 20 power equals 1 plus r over 4. Okay, and this is all gone now. And now all I do is, I'm going to minus 1 on both sides to make this go away. And now I've got 17 over 13 to the 1 over 20 power minus 1 equals r over 4. Okay, I minus 1 on both sides, so I got this minus 1 equals r over 4. And now one last step here, I'm going to multiply both sides by 4, which makes these cancel off, and r is going to equal all this right here. I've got 2 sets of parentheses. I'm going to have to type this in kind of like what I did a while ago. All right, so let me put my calculator right here. I've got 4, parentheses, 17 divided by 13, parentheses, to the 1, okay. If yours doesn't go into exponent like mine does right here, you'll have to put parentheses around it. But mine goes up in the exponent, so I don't have to put parentheses around it. Okay, minus 1, and then I put the parentheses there, and it looks like 0.054. Okay, and it says on here, round to the nearest tenth as needed. Now it's got the percent on here, so that means 0.54. I'll move this over 2 places, which is 5.4%. There it is. Okay. So that's it on this section here. Exponential functions, section 4.2. If you have any other questions, let me know. I'll help you all I can. Have a good rest of the day.